Good morning or good afternoon, wherever you are. I'm Stephanie Boozer with CUGC HQ, and I'm so glad to welcome you to today's webinar. We've got a familiar face, Jarian Gibson, but we've also got another familiar face from days in CUGC gone by, Dave Brett. So I'm happy to have him back on my webinar stage today. But before I hand things over to them, want to just let you know about some events coming up. Excuse me. Next week is our CUGC Exchange Southwest. It's our first event like this ever. We're very excited about it. These are different than the CUGC XL events that you may already be familiar with. They're more hands-on, deep dive, workshop type things. So if you're going to be at the EUC Masters Retreat next week, or if you're not going, but you're in the area, we'd love to have you take part. I know Carl Webster is doing a great session. It's going to be massive. I think this is like he's going to give everyone all his files, all his scripts. It's a big deal. So we're excited about that. And then coming up next is our Exchange Southeast in Nashville. It's going to feature Rich Faulkner. He's going to talk a lot about NetScaler. So definitely check those out. And I'll put a link in the chat for you in just a bit. Also, we're really excited to let you know that CUGC now has a Slack and Discord channel. Massive thanks to Jarian for helping get this set up. He has been working with us diligently along with John Bukud to get this going because it's a big undertaking. So thank you, Jarian, really appreciate it. You guys can scan that QR code and sign up today for either channel or both. They mirror each other. So definitely pick your favorite one. And I'll put a link in the chat to you again for that page. All right, just a couple of housekeeping details. We are recording this session. You'll get a link to that recording tomorrow. So be on the lookout for that. Please type your questions in the Q&A panel as you have them. It's separate from the chat. So we'd love you to stick your questions in the Q&A and then keep your chat in the chat. So definitely welcome you guys to communicate and say hello, tell us where you are, all of that, but put your questions in anytime. All right, so I already mentioned Jarian and Dave, but here they are again, Jarian with a different haircut, and I have been told I have a new picture I can use going forward, so I'm very excited about that. Both Jarian and Dave are CTPs. Jarian is a leader of our Kansas City Metro group, and Dave, back in the day, we had a NetScaler or a networking special interest group with CUGC that we used to run, and Dave was one of our leaders of that. So always been involved with CUGC and glad to have you both here with us today. So I think that gets us set up. I'm going to let you guys share more about yourselves. So Dave, you can, I think you're sharing the screen. I'll let you take over that control and get us going. Oops.
Can you see that all right?
Yes.
All good.
All good. Right, thanks, Stephanie. Thanks for having me again. It has been a while. You're right. Nice to be back. Okay, so today we're going to talk about WEM performance management specifically and considerations when running that. Brief run through of the agenda. Just going to introduce myself and Jarian. Going to run through what is WEM and how it can apply to you. Some of the testing details. So during the test, like how we had everything set up, why we did it the way we did it, and so forth, and then run through some of the results. So the results around CPU optimization. And also memory optimization. And then just to write the word one more time, we're going to go through some of the optimizations and the reasons why we did some of the optimizations the way we did, and also some of the issues we saw, some takeaways. And then there's some resources at the end if you want to carry on investigating this. So like Stephanie said, my name's David Brett, or Dave. I'm a senior solutions architect with Nutanix. Have a background in Citrix networking and Nutanix. Like Stephanie said earlier, I'm a Citrix technology professional and was, prior to joining Nutanix, Nutanix technology champion as well. Jarian, do you want to introduce yourself?
Yeah, hi, I'm Jarian. I'm Dave's guy in the chair today, so I'll be watching the chat and the Q&A. I'm also, Dave and I are on the same team at Nutanix, so we work together working on different things that you see on our portal and content we put out there. And Dave did a lot of great testing today, so looking forward to what Dave's presenting here.
Thanks. Right. So let's move on. What is WEM? There's a nice quote up there that Citrix put out there about WEM. It uses intelligent resource management to deliver enhanced performance, desktop sign-ins, and app response times for Citrix CVAD. And it's driver free. If we look at that in a bit more detail around the key components that WEM has, we're going to break it down into 4 sections here. From an administration perspective, if you're using on-prem, you have the management console, and if you're using the service, you've got the web console. One thing I want to point out up front here is that everything we tested when we were looking at performance management can apply to both the WEM service and the on-prem deployment. There's no real difference in how the testing would be done or the results that we got, regardless of which platform you're using. Again, looking at the admin, if you're on-prem, you do have infrastructure servers, whereas if you're in the service, you've got cloud connectors. There's an agent on the VDAs, regardless. And if you're using on-premises, then you will have a SQL server, whereas if you're using the WEM service, Citrix will take care of that for you. It does do profile management. So it will look at Citrix user profile management. It will deal with user profiles, and it will deal with FS Logic's profile insights. The security side of it, I've used and looked at a lot. Not relevant to this presentation right now, but it's worth looking at these. You can do app security, process whitelisting and blacklisting. It's integrated tightly with App Locker, and you can use privilege escalation. However, the bits we're looking at today specifically are the RAM optimization capabilities, as well as the CPU optimization capabilities that are built into WEM. And as a result of that, login optimization. Now, we didn't initially go out to specifically dig into login optimization, but what became clear right at the beginning of the testing is if we didn't optimize the image properly, then we were seeing a direct impact on how the RAM and CPU optimization worked. Moving on to the testing software we're using Login VSI at the time. Now this provides performance insights for virtualized desktop and server environments. It can test all phases of the VDA operations, from deployment, from implementing changes, and you can incrementally check how the performance of your VDAs is affected by a specific configuration change. In our case, it was like CPU or memory optimization in WEM, and we could baseline it and then test after each change to see the impact that had on the density that we could get on the Nutanix kit. All the sessions we did, so building the test, we wanted a consistent test across everything that we were doing. So all of the sessions were started within a 48-minute window. The response times were measured during the test, and the VSI max is the number we got to before the system was deemed unworkable. So the way that works is Login VSI will work out a VSI baseline, which is the average app response time of the first 15 measurements. And then the VSI max is reached if the VSI response becomes bigger than the baseline plus 1,000 milliseconds. So we would baseline the platform and we'd load it with users until we reach that number. Sessions were all launched from a launcher machine with full HD screen. We were getting around 10 to 25 sessions per launcher. And the workload we used was the power user. So login VSI, it will offer 4 workloads: the task worker, which is a light worker, an office worker, which is medium, as well as a knowledge worker, and then the power user, which is considered a heavy user. This is the one we chose, which will use around 8 to 12 applications. It tries to push the CPU to 119%-ish, and reads and writes, it will go to around 130% capacity, and it will use about 2 gig of memory. We also, once we'd ramped the users up, we left it in a steady state to enable memory management and the CPU optimization to build up and work. And then the measurements that we took back from login VSI were the IO write, which is the CPU writing random data to the disk, and the CPU calculate measurement. Looking here, this is how the data came back to us. So along the bottom, you'll see that as the number of sessions grow on the axis going up, you'll see the response time getting higher and higher, and you'll see an X when we reach the VSI max. And effectively, this is kind of what we're interested in. The VSI max number, the bigger it is, the better it is, and the lower the VSI base is, the better it is. Moving on, the infrastructure we used. So we used NX3155G8 node, Nutanix node. The CPU we're using is up here. It had 2 of these CPUs with 36 cores in each, which gave us 72 logical processors. Hyperthreading was enabled. So in total, we had 108 gig of CPU capacity, 1.48 terabytes of RAM. The disk was all 1.92 SSDs. And we'd assigned, at the time, 32 gig of RAM to the CVM on Nutanix. And we were running the long-term service release of AOS. And then moving on, regarding the images we used for the testing, the Windows 10 image was 2 vCPUs, 4 gig of RAM, a 64 gig disk. The VDA we were using for this testing was 2203 CU1. Not CU2, and the WEM agent was 2212. And with the server image, 8 vCPUs, 46 gig of RAM, same VDA, same WEM agent. And more specifically, for the Windows 10, we were doing a one-to-one mapping between the users and the VDA, and we ran 230 users on 230 machines on a single node. So when we did this test, whilst the Nutanix cluster we were testing on had 4 nodes, we would restrict everything down to a single node so we could get consistency with the test and repeatability. So it wasn't just auto load balancing across the entire cluster. And with the server 2022 image, we would run 310 users on 16 VMs. So looking at the CPU optimization, specifically in the settings that we defined, for the baseline, we would have no settings defined whatsoever. Now, we would still have the WEM agent on the VM, and it would still be in a configuration set. So it was built as per the images where we did enable CPU spike protection, and it was pointing back to the WEM infrastructure, but there was nothing configured. Everything was default. It wasn't part of a configuration set. Then we did CPU management set to manual. So we did enable spike protection, but we customized the settings around that, where we put the limit to 1% less than a single core of the specific VM we were trying, so it wouldn't max out a complete core. So for example, if we had 2 cores running on one of the VMs, the max CPU spike protection would enable that is 49. We did enable intelligent CPU optimization and intelligent IO optimization with run 2. And then the third test we ran was the same with regard to intelligent CPU optimization and IO optimization, but rather than manually define the settings around how we were protecting against the spikes, we let WEM do it for us. So we did enable spike protection, and we customized it and put the tick in auto prevent. So let WEM deal with picking up when we were seeing spikes, and then reduce the priority based on that. Something else I just want to point out here. So when we did these tests, for each test, we did 3 runs. So for the baseline on the Windows 10 image, we would run a 230 user test end to end, reboot all the VMs, reboot all of the launchers, and then rerun it. And we do that 3 times. And then we take that average from the 3 runs for each of these tests. So this this entire test here, excuse me, was 9 runs in total, 3 for baseline, 3 for manual, and 3 for automatic, just so that we could be sure the results we were seeing were consistent across all 3 tests. So this is what we saw initially. This is the VSI Max for CPU optimization on Windows 10. You can see, like, from initial, when we initially looked at it, we were like, well, that's all quite grouped quite close together. So if you zoom in on where these VSI Max values here, you can see that the 3 on the left are when CPU management is set to manual, and the 6 on the right are when it's the baseline and when it's set to automatic. So what we saw on that was the VSI Max was varying from 209 to 224, which is a difference of 7% across the range of those 9 tests. Looking at the CPU for all of the runs, so this is the average CPU usage across all 9 runs. We saw that there wasn't actually that much difference. So the CPU was doing what it should be doing, and we weren't seeing any spikes. So then we started looking into the response times for the Windows 10 image. And you can see the VSI Max here. This is the max for the baseline. And then if you move on, there's very little change between the baseline and when CPU management was set to automatic. Oh, sorry about that. And when we enabled CPU management to manual, you can see here that that's when that VSI Max went down. And if we look at the IO that we were seeing through the platform at the time, with the baseline and CPU management set to automatic, that was very, very similar. And then again, the VSI Max would drop when the CPU management was set to manual. And what we saw here, you can see it's a very similar IO graph when we're using the WEM managed spike protection as well as on the baseline. So it's not impacting the CPU too much or the IO too much. But when we started forcing our settings down onto the platform, we then saw that impact how the CPU was responding as well as the IO. You can see there's these spikes coming up here, and it grows a lot quicker, and that was pulling down the number of users we could get on the platform. So moving on, if we looked at CPU optimization for the server 2022, we saw a similar thing. So when we were running these tests without looking in too much detail, everything is grouped quite closely together. And I think that's purely because of the scale that we were running this at. But when you zoom in, you could see the same thing. So we saw the baseline and automatic over here on the right-hand side. So the VSI max values for those were higher. Whereas when we started pushing our settings down onto the platform, we saw that VSI max drop a bit. And in the case of server 2022, we saw a difference. So the lowest value we got was 227 for the VSI max, and the highest we got was 250. So that was just with CPU optimization. That was a difference of 23 users or 10% per node. This would be, so if you scaled that up, that would make quite a difference. Interestingly, when we looked at the average CPU usage over the course of the test, so this is 9 tests averaging out the CPU across all 9, we saw CPU usage was slightly higher on the Windows Server operating system than it was with the baseline and manual. Whereas with the Windows 10, it was more kind of in lockstep. So there is a bit more of an impact on the average CPU usage when you're using this on Windows Server over the course of our very specific tests. So the results of these will vary quite dramatically depending on the workload and the environment you're running it in. But with our controlled testing, we did see that higher, and we saw it consistently slightly higher on the automatic, whether that's because it's not a one-to-one environment, because it's the WEM agent is dealing with multiple users on the same VDA, is probably the reason for this spike. Oh, there we go. And looking into this in more detail regarding the response times, so you can see again with the baseline, the VSI max sits up here right before we start seeing the response time starting to creep. Drops slightly when we set it to automatic, but not noticeably. And you see the response times increase a lot quicker when it's on manual. And the same with the I/O. So we don't see a great deal of impact on the I/O. We saw only when it started going above VSI max, apologies, we saw what is going on? There we go. When it started going above the VSI max, we started seeing the I/O be impacted. With this, when it's on automatic, the same. And this is what we attributed that spike in CPU, or the slight rise in CPU. It is doing more in a multi-user environment when you've got it set to automatic. But then with a similar thing, we saw the same when it was on manual. But the VSI max on the manual setting was lower than automatic and baseline across the three tests we ran.
Hey,
so yes.
So back on just a quick question here. So you would say more it's a single session versus multi-session than a OS difference then, probably, if you were part of it, would test it again.
Yeah. So what we saw was with the one-to-one mapping, with the Windows 10 testing we were doing, the CPUs were super consistent across all of the tests, and we saw like the same results every time. We saw regardless of what configuration we did, the actual CPU usage was fairly level. Whereas with the multi-user side, once we set it to let WEM deal with the spike protection, we did see it eat more CPU up without digging into how the product is designed, like under the scenes, we were assuming that it's doing more in the background. So it's looking at more processes, it's dealing with like the spike protection table. I'll come into how the WEM agent deals with the spike protection long term later on, but we put it down to it's having to do more behind the scenes to protect you from those large CPU spikes, which is why it does increase the CPU slightly, but it wasn't overall, it wasn't affecting the VSI max too much, as in when we had it set to automatic and manual. Does that make sense? Cool. I just see a question from Adam, which WEM are you using, on-prem or WEM as a service? So we did all of this testing with the on-premises version of WEM, but like I mentioned earlier, because of the way this works and the settings are pulled down to the WEM cache and then it's applied locally on the VDA, you can do this with WEM on premises or WEM service. It would make no difference to the results of the testing. Okay, moving on. If we have a quick look at the memory optimization. So again, we did 3 tests on each of these runs. The first test was to baseline it, to see how the Windows 10 and Windows Server operating system performed with no memory management enabled. This was also a base image that we installed. It had the WEM agent on the base image and it was pointing back to the WEM infrastructure. And then we enabled memory management. This is the memory management that will try and trim memory for idle processes. This isn't the remote desktop session host memory management, which we'll talk about later on. This is active trimming of idle processes to save memory on one of your VDAs. We put do not optimize when the available memory exceeds a certain amount. So if we have a look at how Windows 10 performed with memory optimization enabled. Again, we did this for 3 runs on both. You can see even when you're zoomed out, there was a noticeable difference. And this is one of the things that we saw consistently. We ran hundreds of tests on this thing, and memory management, when it was enabled, the VSI max was down here, a lot lower, and when we switched it off on the baseline, we were getting a lot more users per host. So in this graph up here, the VSI max is varying from 200 to 224, so that's a 12% difference. Oddly, and again with memory management enabled and switched off, the CPU was fairly consistent with the one-to-one. So going back into those 2 metrics that we were looking at earlier for the CPU optimization, but this time with memory optimization. This is the response time. So the app response time for Windows 10. You can see here, this is the baseline. And then this is the memory management when we had it switched on. So you see that there is quite a big difference between, you can see the VSI max here drops right down and the response time starts going right up. So this is clearly the breakpoint for the amount of users we can load onto this node whilst we have memory management enabled. And if we look at the IO profile with the same test, see the IO starts ramping up here and then we see it maxing out here when we hit the VSI max. And whilst there is more IO leading up to this, we don't hit the VSI max until this average starts coming up as well. And overall, that is pulling the VSI max back. And if we do the same with Server 2022, whilst we had one kind of lucky run here, I put it in there for honesty, that it was consistently lower. The VSI max was lower every time we had memory management switched on as opposed to the baseline. So the difference in this is that one of the biggest we've seen so far, where the VSI max was varying from 210 to 249. So it's a difference of 39 users or 18% in our tests. And we did 3 runs on the baseline, 3 runs with memory management enabled. And on here, again, the CPUs are very, very consistent. We weren't seeing the CPU having to work harder to offload that memory. And then the response times. VSI max here, this is around the response time on the baseline. And if you compare that to the response times when you had memory management enabled, you can see that VSI max there is dropping across here, and you can see the response times once you go past that VSI max starts going up and down and fluctuating quite a lot. So there's a clear number that we can get to and have the performance of the platform still operating as we would expect for the users. Something I did want to point out, so our happy place when it comes to the CPU usage on AHV is around 85%. So we'll want a steady state of 85% and lower. So we'll ramp the tests up till we hit that. And then what we'll typically see is it will go up and then drop slightly. And then as steady state kind of carries on rolling, it will level out just under 85%. And that's where we push these tests to. And then if we have a look for the Windows Server regarding the I/O, you can see there's not a great deal of I/O here when we're running this on the baseline. But when we enable memory management, we see that I/O, once we start going past that VSI max, it starts going up and down a lot. So we're seeing a lot more activity with regard to disk I/O. So that's the data. Apologies for the onslaught of graphs. I know it's a lot.
Hey, let's take a quick break real quick. We have 2 polls today, so let's go ahead and do the first poll, Stephanie.
That's a good idea.
And then Dave, while that's going, there was no test on any other hypervisors, correct? Just all AHV, right?
Yeah, this was specific to AHV. Did we get all the questions answered, Jay?
How are we doing on the poll, Stephanie?
Sorry, I was on mute. So I just finished the first one about hypervisors, and I think you should be able to see the results.
Yes, looks like majority is going to be on ESXi here with the next AHV, some Zen server, a little bit of Hyper-V, and then something else. So it's good numbers there.
Yeah.
You want to run the second one?
Do you want to run the second one now, Dave, or do you want to wait?
Why don't we let me talk about optimizations and what we did and why we did it, and then do it before we do the takeaways, if that's cool.
Yep.
Good stuff. Okay, so optimizations. The reason, so as part of this test, we needed a controlled environment. So we have, by we, I'm talking about Jarian, myself, and the other guys in our team at Nutanix. We have a method of deploying our master images that's completely end-to-end. We don't touch the images, and it means that we can reproduce the image the same way every single time, regardless of which operating system we push down to it. So when we started the testing, the Windows 10 image worked great. We put it in, we ran the baseline, we ran the WEM test, and we weren't seeing the CPU was like, it was going up gradually, it was going up in line, they were all doing the same. However, when we built the Server 2022 image, we saw this bump every time we did a test. We would switch it all on, everything would work, and then we'd start the test and we'd see this huge spike in CPU, and then it would drop out, and then it would start to grow and act as we would expect it to during a VSI test. So what we initially thought is maybe that's the WEM cache. So it might be that as the multi-user servers are booting up, it's pulling down all this information from the cache. So what we did is we changed the pre-idle time to allow the cache updates. We had a longer rest time at the start of the VSI test to try and let things settle more. We even took, I think we took that up to an hour and a half at one point. And all that happened was that bump moved. So the bump would keep moving depending on where we were monitoring. So we were monitoring with everything sitting, no users logging on. And as soon as the users logged on, we would see this huge spike in CPU, and then everything would settle down and we'd start the steady state again. So what we had to do is start looking at the optimization tools. So we looked at, there's two different tools that we will typically benchmark against. They're the two that I would imagine most of the people on this call are using. You've got VMware Optimization Tool or Citrix Optimizer. They both do their job very well. One is more aggressive than the other in that it will deal with more. Some of the big things that I wanted to point out regarding OS optimizations, we saw a huge impact on the numbers based on the optimizations we did to the image. Scheduled tasks was a big one. So the optimization tools natively will deal with a bunch of scheduled tasks, but there's stuff that will impact how the WEM testing, it will impact the output of the WEM testing based on how many users we could push at the system, purely because of scheduled tasks that were left kicking around that were executing at logon. One of these tools, I'll let you do your own reading on which one, but one of them is way more aggressive on the default user profile. So your initial logon for that user might be a little bit faster. However, there are, with Citrix Optimizer, there's a stack of community templates available that you can get and load into Optimizer to do additional stuff that it may not do out of the box. The other thing I do want to call out is the community tools, so BISF. So using it in specifically Citrix Optimizer alongside BISF would give you a very complete optimization process for your image sealing. But again, you need to test and compare. This isn't just for the WEM performance optimization, this is for everything. What we did notice is we were using the version of Citrix Optimizer that was coming out of our build process. And then I saw a new version come out that said added support for NGen on Windows Server. And that turned out to be the cause of the spike. So the version we had the, looking at the template, so if you dug into the template a bit, you would see it would do all the NGen, the .NET work for the Windows 10 image, but it wasn't doing it for the Windows Server image that we had. And that's why we were seeing that big bump in the CPU graph as the users were logging on. Then it would settle down and then continue to climb. So the point of calling this out in here is just we got bitten by this. just by having a version that was one behind the latest release. It's worth looking at the version of Citrix Optimizer you're running, and if you haven't upgraded it or got the latest one, it would be worth looking at that, especially if you're using multi-user environments. And that's outside of kind of the WEM testing piece. Do you want to do the next poll, Jarian?
Sure. Stephanie, you want to launch that for us, please? Do you plan to use the same VDI broker in the next calendar year? We've gotten some good questions so far. I've been answering in the chats and in the Q&A. But there's one while we're doing the poll. The main thing that had impact on density was the manual on the Windows desktop, correct? Was the main thing that impacted density? But
yeah.
But overall, WEM's not really impacting density overall by using the performance optimizations.
No, not per se, no. And I'll get to that. Yeah, I'll speak to that in a minute.
Okay. Looks like we're doing the poll. So it looks like majority of you plan to use the same broker. Some say no, and then few are unsure. And that probably could be moving from CVAD to DAS, or from DAS back to CVAD, or do not know what their future plan is. So good poll there. Go ahead, Dave.
Yep. Okay. So looking at the results of the testing we did. So we did run these tests within a specified time frame and under very kind of tightly controlled circumstances. And that was to give us a basic look at how WEM system optimization features impact performance from the outset. But given how Citrix WEM and the system, specifically the system optimization, is designed, it's worth keeping the following points in mind. So the WEM agent records the history of the processes that are launched on the machine that triggers spike protection. It records the number of times that process has triggered it and the user from whom that spike was occurred. And what that means is over time, the WEM agent gains insight into which users are triggering which spikes and how to handle those more intelligently. So if you enable the intelligent CPU optimization option, what the system will do, it will flag processes that spike the CPU, and eventually over time, it will learn from that. So say a process gets flagged as causing a CPU spike, and then another user launches it, it will flag it again. Over time, it will learn from that, and it will launch that with a lower priority. And therefore, the longer you let it run, the more level your CPU will become, because it will have a history of the processes that are troublesome, and it will level that out. The testing we did showed that CPU management, and more specifically the spike protection, works best and had less impact on the baseline when you use the auto prevent CPU spike option. That's when we noticed the smallest difference between the baseline and the VSI max value, i.e. the less impact on density. The highest impact was when we started trying to define those numbers ourselves and force WEM into what it would consider a spike. For both Windows 10 and Server 2022, the VSI max value for us dropped significantly when we enabled the optimized memory for idle processes. Now, just an important point to make on this is that this isn't necessarily it's not necessarily a bad thing to implement, but it is worth considering. It could be a great technology if you have a memory constrained environment. However, just be careful that by enabling that, you don't inadvertently affect the user experience that your users are having just to save on memory. One other option for not the one-to-one workloads, but for the RDSH workloads or the many-to-one, is to use the multi-session optimization feature. So rather than drain or save memory from an idle process, what that's going to do is it's going to drop the memory, but only for disconnected users. So those users themselves aren't going to see the impact because they're not even on the platform, and it will save the memory from them, as opposed to actively trying to save memory from idle processes on the system. And finally, the time benefit of it. So because of, again, the way it's designed, the CPU management is going to become more beneficial for your VDAs over time. We would recommend, certainly on Nutanix from the testing we did, to use the auto prevent CPU spikes, because that had the least impact. Say use the memory management with caution, as it does affect other areas of the VDA performance. But there is specific use cases for that. And to wrap it up a little bit early, there is a tech note that we wrote. So if you're a Nutanix customer, I believe, if you go into the My Nutanix portal, then there's all of this information plus a bit more on there. You can download it as a PDF, print it out, and check on how that would affect your environment. You've got the WEM and the WEM service documentation up there as well, just as easy links if you want to look at how to configure any of this stuff. And with that,
there's some questions here. Do you want to look at the Q&A and see Donald? And I'll pull up I'll see if I can pull up a public link to the guide.
yeah, it depends. So it depends on where the cache is for the settings for the WEM agents. So if you redirect them to a persistent disk, yes. Again, it depends on if your reboot cycle is once a week. I don't know if it's every night. It may well wipe that, but once a week over the course of that week, it's going to learn it. We left it running for, I think we did 40, 90 and 120 minutes over the course of the data in the graphs you've got up there are the last 3 runs we did of each of our test scenarios. Leading up to that, we probably ran, I don't know, close to 50, 60 tests, testing different configurations, trying to iron out any of those bumps that we saw. Also, if you know, how does WEM compare to Avanti? I couldn't answer that. Jarian, you got any idea on that?
Yeah, I'm not sure. I haven't touched Avanti in a long time. Their performance piece that they got with AppSense. Yeah, I haven't touched that one in a long time, so I'm not sure how it compares. I always use WEM because WEM is, comes to your entitlement from Citrix. You don't have to pay extra for it, so that's where this came from with the WEM testing.
Yeah. Not sure on the TS fair share. Is a 30-day refresh cycle too long? It depends on your use case, I guess. Would tweaking the idle time setting for memory management be worth testing? Yeah, I would say so.
And then we had a Windows 11 question I already answered. I said that we could probably test it and update it next time we do a refresh on the document. We could test single session Windows 11. Unfortunately, multi-session Windows 11 is not available on-prem outside of Azure Stack HCI. And then Drew, to answer
Glenn's-
the idle state one.
It's mentioned in memory management. So well, I've set them was set to -1%. I think we tried it at 1, 5, and 10. Again, in the leading up to, I'll get the specifics are in the tech note of all the information and the settings that we had.
I have the link. I'm just trying to check if it's publicly available or if it's behind a login. If not, we can always, I guess, send a PDF out too as well.
Yeah, I think it's customer only.
Yeah, it's behind a logon.
Regarding Citrix optimization, this is from Glenn. Would you recommend running it when finalize the image or via WEM during boot? So personally, I would do it when finalizing the image, but that's just my preference. You can do it either way, I guess. But I tend to run it, if it was me, I tend to run it as part of BISF as an image seal. Jarian, I don't know what your thoughts on that. When would you run your Citrix optimizer?
I always run it every time I seal. That's when I run it, because you never know if some update or something changed or reverted something. So as part of my seal process, I run the optimization tool, whether it's VMware, whether it's the Citrix one, whether it's your own script or, BISF, or even like the BPA, anything that you do for optimization, I always do that every time as part of the seal process to make sure that every time that's rolled out, it's got those optimizations done.
Yeah. Some of the other optimizations as well, like if you're changing some of the network stack settings and bits and bobs like that, require a reboot anyway. So I don't know how, not specifically the Citrix optimization stuff, but if you've got some bits and bobs in your script that you were running via Citrix optimizer on boot, it might not take effect until reboot, in which case you might lose those gains. At least that's how I would look at it.
And the one thing you point out too early on, make sure that you look at custom templates or doing things to optimize that first logon, because things like active setup and other things, when they first create the profile, that can impact that first time experience as well. So, Optimizer is a good job, but I don't think any of the templates built on take care of that. I know Rob from the app layering team for Citrix, he has that custom one out there that you can get in the community feed for Optimizer. Well, it can do the default optimizations for you. I'm not sure about this one. The Citrix Optimizer from WEM is meant for persistent VDI. Is it true to say that enabling memory optimization that will increase IO? It can, because what basically it's doing is paging to disk, and so that can impact your storage performance on the memory one.
Yep, that's certainly what we saw.
I think we are good there with questions. Stephanie, do you want to take it away? Because I know you have something you wanted to put out there, another poll as well.
Yeah, so is this the same team that's coming back in April?
Are we coming back in April, Dave?
I think we are. Yeah.
Let me put you on the spot right now. Okay, so I do know we are holding another webinar on April 27th, and I think we're still finalizing the topics for that one, and I feel mostly confident it's going to be Dave and Jarian again. But either way,
is that the EMEA friendly one?
Yes.
Okay, I think that's Dave. I think I'll be riding shotgun again with Dave.
Okay, so yeah, just if you're interested, we can go ahead and get you pre-registered for that. So so I'll do that, and then actually I have a request here for the Discord link.
No, he's saying put the invite out there. So the next invite for.
Oh,
No, I read it wrong. Never mind. He's saying put the
Okay.
Discord invite out there. I'm sorry. I read that wrong. I thought he meant throw the webinar invite on there.
well, we can do that too. Yeah, all right, there it is. It's in the chat for you again. So hope to see you over there. And looks like a lot of you would like to come back in April, so that's awesome. I'll go ahead and close this out. And I think we're set. I know some of you may have opted in for a chance to win an Amazon gift card. So as soon as I close out this webinar, I will pull the report and we'll do a random drawing and be on the lookout for an email letting you know you won. And other than that, I think we're good. There's no more questions that popped up at the last minute, right? I always like to check. No, I think we're good. All right. Thank you. Thanks, Dave. Thanks, Jarian. So good to have you back, and looking forward to April.
Thank you.
Thanks very much.
All right, guys. Enjoy the rest of your day. See you again soon. Bye.
Bye.
Bye-bye.